An electrolyte is a substance that yields ions in a solution. We can have strong electrolytes and we can have weak electrolytes. A strong electrolyte is something like sodium chloride. It dissolves completely into its ions. A weak electrolyte is something that doesn't dissolve completely. A little bit of the ionic compound remains in the solution as well as some of its ions. We also have substances that are called non-electrolytes. Sugar is an example of a non-electrolyte. It does not break apart. It simply is surrounded by solvent molecules in order to dissolve. Electrical conductance can be used to determine if we have a strong, weak, or a non-electrolyte. Strong electrolytes conduct current very quickly. They have a low capacity for resistance. A weak electrolyte will conduct some electricity, but it's not a freely mobile system. A non-electrolyte will not conduct electricity. Polar solvent molecules are attracted to ions. This electrostatic attraction between the ion and a solvent molecule with a dipole is called an ion-dipole attraction. So these attractions are important to the dissolution of ionic compounds in water. Under most conditions, ionic compounds will dissociate almost completely when they are dissolved, and most of them will be classified as strong electrolytes. At the atomic level, the ion-dipole forces of the water attract the positive end or the hydrogen end of the polar water molecule to the negative side of the potassium chloride or the chlorine side. The negative side of the water molecule or the oxygen is attracted to the positive side or the potassium of the ion. So the water molecules end up surrounding each of these ions with the appropriate side, and that reduces the interionic forces that bind the ions together. There are some covalent compounds that, when dissolved in water, produce an electrolytic solution. These covalent electrolytes form ions in water. So they either form a hydronium ion or a hydroxide ion or both. Typically, these covalent electrolytes will be strong acids. HCl is actually a covalent molecule. Remember from Chem 1 that we can classify the type of bond we have with the electronegativity difference. The electronegativity difference between hydrogen and chlorine is 0.9. That puts it squarely in the polar covalent bond range.